All right, so what we're going to do, so our test B sovereign network is down. We allocated some more resources to it and rebooted everything and it didn't come back up, and we need to SSH into the box, but we don't have the access for that. So what I'm going to do for the period this afternoon is I'm just going to demo the workshop. I've set up my Play with Docker to connect to our development environment. So I'm connected to our development B sovereign network, our development orgbook. I'm not going to give out the IPs or configuration to everybody because we don't want to bring that one down as well. But I'll run through the whole thing, and if you've got questions, you can ask questions, and I guess you can. We'll keep this document available. If you want to run through it on your own, feel free to ping us with questions on Rocket Chat. We're going to record a video of it as well, so that we'll post that sometime within the next week or so. We've got another workshop tomorrow. We're going to try beefing up our B sovereign network to handle more load, so you can try coming around. Plus, I'm going to be around this afternoon and tomorrow afternoon, so if you find me or just ping me on one of our many communications, then I can answer questions over the next couple of days as well. So what I've done, just to confirm everything actually works, is I changed our so these configuration files that we looked at earlier, I updated the settings to point to our development environment. So I'm just going to do a demo this afternoon. We're not going to do kind of an interactive workshop. So anyway, so I've configured it to point to our development environment. I've set my host name. So I've done the first couple of steps. I set my host name, and then I ran the init script, init.sh, to set my DID. So my new org name is Ian Co-Issuer Mach 2 on December 14th. And it's registered my DID on the ledger. So my DID, so based on this seed, my DID is F29 blah, blah, blah. And then it went through and it updated all of the configuration files so that they're all now configured for my environment. So we went through the configuration files earlier, so I'm not going to do that again, but I'll just go to the config. I'll open the schemas, and you can see now that the name of the schema now has my org name in it that I specified through the init. So all of the schemas are now unique to me. So when they show up in the orgbook, they'll show up under me. And for services, I've set the issuer name to Ian Code December 14th Workshop Issuer Second Try, so we can see the schemas and the credentials when they show up on the orgbook. So I'll follow the intent of the workshop anyway. So I've cloned the repository. I've set up my host name. Actually, let me just double check that I've actually done that. Have I done that?
Oh, it got erased because you pull request. So run that set host again. Set host.
Okay, well let me just double check and make sure. Good thing I checked.
Yeah.
So there's my host name. So I'll do .set host. So I have my endpoint host now. So when I register, people will know how to talk to me. I've run the init script and updated all my local configuration.
And registered the DID.
And registered the DID. I've changed the name to something that's a unique value, very unique.
No, just unique. They gave me a problem today because I said very unique, which is probably a stupid thing to say. So I took it all out because they were bugging me.
So I'm going to just go to the ledger, which is, where's my ledger?
159.
Yeah, this one. So if I go to the domain and I search for NIM transactions, I'll just go to the end. I'll just search for mine, Ian Co. So the last transaction in here should be the NIM that I just created. V4? I can't remember. Anyway, you'll have to trust me on this one.
So just so you know how we're doing that ledger browser is we actually run a server which is polling the ledger, and every once in a while we just hit it as a trust anchor and say, hey, tell us about transaction 79773 and 74 and 75 and 76, and that's all we're doing. Then we save it off in a database. So we're basically making a copy of the ledger. It's immutable, right? It won't change. So, and then we just poll it.
So there's a little bit of a lag in terms of updating that.
Yeah.
So I'll just go through and do a build now. So the next step that I need to do is actually build the agent software. So I cd into the Docker directory, and I run manage build and manage start. So cd docker. So if you do ever decide you want to build the whole thing on your own, then there's other repositories. They're all under BCGov, and they've all got a similar structure. So they're all Docker based, and they're all based on this manage command. So if I do manage build, it downloads a pile of stuff and builds my local Docker images. So this is installing the agent software on my local machine using Docker-based installation. So there's a base Docker image that includes all of the Indy SDK, Python wrapper, our Postgres wallet software, as well as the software that we use for the agent-to-agent communication. So there's a software that we call VonX, and essentially it's a peer-to-peer agent. So there's actually VonX runs in the OrgBook, and VonX runs in the agent. So when you're issuing credentials or creating schemas and issuing credentials, then it's the VonX pieces that are actually talking to each other that understand how to talk to the OrgBook.
Did you bring up the diagram? Some people have asked about that.
Oh, I closed it. We'll
Do that.
do that in a bit.
Because I think it's hard to understand all the bits and pieces.
It's hard to conceptualize, but
We have an architecture drawing that we can go over when the time is right.
I feel good about this time.
All right. Can you switch to that? Did you close it?
I closed it.
It's just Vonnex. It's just Vonnex to hide.
Here.
But it's in the footer. It's easy to find.
I don't think it's what he wants to do.
I know, but people need to
Scroll to
understand.
the bottom.
They don't understand.
Quick BC's Von architecture. We can't make it a whole lot bigger because it won't fit, but so I'll use those. Okay, so you start with the sovereign network. So this is out somewhere on the internet. We don't really know where. We load a Genesis transaction file that tells us who to talk to and how to talk to that. So it's just out there. The ledger is out there somewhere on the internet, as well as a person who uses the website, and can be other clients that are just using the OrgBook API. So they're just doing queries about companies and what credentials they have and so on. So that's the internet side of it. An issuer is up here. So this is an example of the BC Registries issuer. So in this case, they have their own system, and they've got a Oracle Enterprise database that they manage all their data in. What we did is, again, we're trying not to change their world at all. We're trying to be as light a touch as possible until they see the value and want to increase that. So what we did was we just used a Postgres data wrapper, which allows us to have a read-only view into their database. And then what we do is we've got an events processor that monitors the database for when an event occurs. Hey, a company was just incorporated in British Columbia, and oh, these two companies dissolved and merged together to create a new entity.
And this company just did not renew, and now they are no longer a valid company. So we're just looking for events. Whenever we see an event, we fire it over to this generic component, this VonX component that John referenced, which is we just send over the JSON of the credential through a REST interface to say, hey, go create this credential and send it to the org book.
And that's what you're configuring. That's where the schema YAML, services YAML, it's that box that you run that is the thing that allows your service to become an issuer verifier. All of the magic is inside that.
Yeah, for an issuer verifier.
That's Indy SDKs in there, a thing we call Von Anchor, which is like an abstraction above the Indy SDK and the RESTful services that you need.
So I'll highlight that there's also DID off going on here. So one of the things that BC Gov did was they put a bounty on creating an implementation of DID auth. And those in the community might know Marcus Sabadella, or Peacekeeper as he's called, in the Indy community and various other communities, W3C and DIF. He's the guy that created the universal resolver, so he won that bounty. He created a DID auth mechanism. So each time these components talk, they authenticate via the DIDs, and there's a whitelist. Right now, it's just a whitelist over here that we maintain of what DIDs do we want to allow to talk to us. So if you're not an issuer that we know about, you will not be able to issue to the TheOrgBook credentials until we add that in. So that's a piece we have right now, is just to experiment with the DID auth capability in that. It's a pretty early implementation, but it actually went in really smoothly, and we just keep using it and don't touch it a lot. VonX has a wallet, so there's a Postgres implementation which Ian implemented, so it's running there. And then there's the TheOrgBook.
And that's part of the official Indy SDK now. So the Indy SDK now is like an enterprise-grade wallet, so they can handle millions of credentials and filter on various tags.
So again, we have another component of VonX, so they're just talking to each other, and I've had a couple of people I've talked to about protocols and agent-to-agent protocol. We're kind of shortcutting it because we're controlling both sides of it, and we're just having kind of a proprietary discussion. This is the next piece that we really want to hit, which is making this VonX component an agent-to-agent protocol that other agents can talk to in a generic way that the industry understands, so that protocol of being able to send messages and communicate that way. Once a credential is received, it gets stored in the wallet, and then it gets sent over to the TheOrgBook API, and the TheOrgBook API will then basically parse the elements of the claims within the credential. We'll figure out, based on the mapping that you provide, and that's part of the configuration that Ian's going over today, what fields are relevant for searching. What's a name? The TheOrgBook searches on names and allows people to search on names. So when we issue a credential, the issuer has to say, this field here, that's a name, and people should be able to search on that. And so that's how it understands the mapping from the credential into a generic data structure that the TheOrgBook understands. And that's how we do, make it generic so that it can handle, it's agnostic of any specific credential type. So there's not any specific BC definition of a credential in here. It just says, you tell us what your credential look like and how it maps into the search capabilities that we provide, and we'll go from there. Fires it into a database, and Angular 4 JavaScript web interface on the front of that. So all of this in our world is running on OpenShift, and so what we can do is, these are containers. Basically, the API is a container, VonX is a container, Postgres is a container. So what we were able to do in loading, we talked a bit about this on the other day, 10 days to load our first pass at loading all of the data in using a non-Postgres database and using just sort of single instances of things. We had about 2 sprints, 1.5 sprints to 2 sprints. By the end of the second sprint, we'd gotten up to 2,600 credentials per minute being issued, by BC registries and then being consumed by the TheOrgBook. So we're down to 12 hours to load all of the companies at British Columbia, so we were pretty happy with that. But that's basically just taking advantage of the OpenShift capabilities that BC Gov has put in, and just being able to scale up, auto scale, and things like that. So that's more or less the architecture.
So the, sort of the top box there is the BC registries and then the TheOrgBook.
And then the TheOrgBook down below.
So
Yeah.
the BC registries is an example of an agent. So it's an agent, we're building an agent. So it's just the first agent that we brought on board.
Yeah.
So hopefully what will happen is there'll be hundreds of agents, hundreds of issuers. And they can be issuing to the TheOrgBook if they're government things, or they can be issuing to business wallets or individual wallets. So that's the piece that we're configuring and building today. That's the important piece.
Does that make sense?
Yeah, and the TheOrgBook is intended to own Attendees and its wallet from Value.
So while we're discussing, I'm just going to go on to the next step. So I built all my local Docker images. I'm just going to start up the environment right now. When it starts up, it registers all of its schemas and credential definitions. So it does take a minute or so. So I don't know if you want to just kind of continue the discussion while we're...
The TheOrgBook holds credentials. It's better to think about it as a generic thing, a credential, which is a countersigned chunk of data. Sometimes it is data about me, in which case it's an identity. And other times it's a business registration credential or a water taking permit credential or whatever you want. A piece of evidence from a mine inspector. So TheOrgBook is meant to be is a holder. They call it a holder prover. And it's the big difference between the original conception of like personal identity or whatever is that it is a multi-subject holder. So normally the holder holds credentials about a single subject, like me. In this case, the holder is the TheOrgBook. It's holding credentials about millions of subjects, being the individual organizations that are created in the jurisdiction of British Columbia. You can have those, but those multi-subjects could be doctors. They could be professional engineers. They could be nurses or teachers. Anything that you want to share in a public way, or internally, we might create one for our mine inspection service, so that they're holding credentials about mine inspections, and the subjects would be mines, for example.
So in that case, so in the case of the BC
That wouldn't be
TheOrgBook
public.
and the front, these are all public credentials, public data. This is just basically open data presented in a different way, presented in a signed, reusable way. The mine inspection thing that John's talking about, that would be a behind the firewall instance of the TheOrgBook, where it's just basically serving as a database, but wants stronger encryption and signing capabilities that can be looked at years from now. Okay?
Does it mean that the data is centralized still? Do I have any control of my personal data?
So we would, in a public one, we would never put any personal data in. So all of the data you're seeing here is public data. So this is the information that goes on the wall of a restaurant. One of the reasons we started there is because we don't want to deal with public data yet while we learn.
Private data.
So, or don't want to deal with private data yet while we learn. Now, and private data would never go into a public repository like this. This is the weird concept is we're building a decentralized system, but we're doing it by creating a central component, which is odd. But it makes sense because it allows us to build out the network without having everyone have their own wallet before we can get started.
You may have answered this already, Steve, but I'm familiar with edge agents and cloud agents.
Yeah.
And credential registries that can also leverage that agent wallet kind of architecture.
Okay.
Does your repository follow that model, or is it more custom?
It's a fluid model.
Which part are you talking about though? The TheOrgBook is a
So is it actually an agent? Is it actually an Indy agent?
Yes, all of them
All of
are
them are
straightforward,
Indy agents. Okay.
traditional, quote unquote, Indy agents, yeah. So
It's just once you put the term cloud and edge, it kind of gets fuzzy.
forget about cloud and edge.
Yeah.
Like
It's all
the
this- all
DC
agents.
registry has an agent that represents its identity.
And are you
Has a
using
DID.
are you using the wallet code, or is this where you have
Oh,
your
yeah.
custom?
We are using the wallet API. It was
Yes.
modified in order to allow
Top tier.
pluggable stores. So you
Okay.
can choose the MySQL or the SQLite store, or now you can choose the enterprise store, which we
Yeah.
built. And they modified the SDK wallet API to accommodate that capability. Some
So
months
anybody
ago.
that needed a high capacity, high performance
Yeah,
Yeah.
credential registry
yeah,
could use
would
this.
use the enterprise wallet.
So one of the things
Which
you
is
run
now
into, and
built into the SDK as native, like native
So-
code.
we got to stop pretty soon.
Yeah.
But just the other thing about it was because we're running on Kubernetes, we need to restart. Things move around, data moves. So the SQLite didn't stand out to that. We could only have one writer, so we could scale up and things like that. So
Yeah.
that's other reasons to use it. Ian, let's go back to the.
Back
We
to
can
the
answer more questions after.
Back to the demo. This is a demo now. So I've started up my local agent, and it's registered the schemas on the B sovereign network. So this is the interface for the development version. So if I go into the transaction browser and type in Mach2, which was part of my org name, then it will filter on anything related to an organization named something like Mach2. So this has my DID. So this is I don't know if you could read that, but this is a NIM transaction against my alias. And then it's got all of the schemas and cred defs that I've just registered. So there's four schemas.
So just to go through the schemas, so those who haven't seen this type of transaction, this is a transaction on the Indy ledger that is saying that a certain DID, which was the previous one that we showed, wrote that schema, and the schema has a name, a version, and a set of attributes. Right now, that's what a schema is for a credential on Indy. Just that little bit of information. There's no cred. Is there cred defs?
Not yet, because he hasn't fired up the agent.
Yeah, the cred defs should be there. It's just they're not named with that.
I'll just scoot to the end.
Yeah. So a cred def is a credential definition, and it ties the schema that the issuer wants to issue with the DID of the issuer. And what that allows is whenever somebody goes to prove a credential, the verifier will find out what cred def was used. That gives them a path back to who issued this thing. What was the DID that issued this transaction? Now I've got a path back to the issuer. I can now decide, do I trust that issuer?
Yeah, so this is an example of a credential definition. And as you can see, based on all the crypto stuff, it links back to the schema that we just created.
Now, this is a key piece here, like somebody was asking earlier, is that it is the credential definition that is used in the verification process by the verifier. The issuer has no knowledge of that. There's no callback to home to ask the issuer if this is still valid or whatever. It's all contained in the proof that is offered by the holder. In this case, TheOrgBook will be offering the proof. And in that proof is the DID that allows you to look up the credential definition and get the other bits of crypto that you need. Because that's about as complicated as I get in crypto. And then the verifier can independently verify the integrity of that data. So it's a very important pattern for privacy. Later on, we don't want to know when a citizen is using their digital identity to do something. We don't know that now, and we don't want to know. I mean, some parts of the government might want to know, but we don't want to know that because that's surveillance, right?
But right now you do because you operate the
In
order.
any existing, well, no, we don't have independent, we don't have digital identities here for people, right? And the
Not for
OrgBook,
people, but for the organizations, you know,
the
right?
OrgBook we would know when a proof is being offered here.
Right.
But
Yes, yeah,
But
you're right.
that's not the
But that's
case.
the OrgBook,
Yeah.
what was I
Public
gonna
data.
say? And right now, any existing identity system that is not decentralized does know when a person uses their identity and attributes are shared, it's always shared from the identity service provider. So they always know, right? Whether it's Google, Facebook, or the government.
Just within the schemas that you have there, is there any taxonomy that's avoiding duplication or
No.
duplication? And similarly, if you had two different sets of property, maybe one for a corporation registration and another one for, say, a liquor license,
Yeah.
if there's a change on an entity, like they've moved the address, is the other entity that had that same information notified that there is a change?
Those are two different questions. One is there's no like schema, global schema thing. Although, for example, we collaborate with Ontario, we're both using the same schema. So there's a bit of thinking around the emergence of standards-based things, or it could be a UDL-based schema or whatever. So those exist in the world. Part two was about the data. We talked a bit about like in the TheOrgBook case, it could have a webhook. But in the peer-to-peer case, it would be like they don't share with each other because there's no data on the ledger, right? Like you can see there's no actual data on the ledger, just these templates.
I was maybe hearing something different in the question. Like, let's have a driver's license and my TD bank account.
Yeah.
Could they share a common address entity?
They
Is there a
could,
sense of
if there was an
normalized-
address schema, for example, that people liked, they could use it, yes, because the schema is not owned by the person that put it on, or the entity that put it on the ledger. Someone else can create a credential definition based on any schema on the ledger.
But is there the concept of creating credentials, aggregating credentials from smaller credentials?
I think we're
So-
kind of,
Yeah, we're gonna stop on that one.
We can talk about
Yeah,
that.
but let's go back to the demo.
slippery slope. Okay, so I've started up my agent. So I have now an agent running on Play with Docker, and it's talking to the TheOrgBook, which is running in the BC government development environment. And there's two ports that are exposed. 5435 is the wallet database, which is used locally, so we're not really interested in that one. 5001 is the port that's exposed by the web and REST services. So when I connect to that one, hopefully this is the same host name that we configured earlier. And if we want to go to issue a credential through the web interface, we can do that just by typing in the name of the credential. So we're going to just skip that.
And that 404 was intended.
Yeah, so we don't have anything configured on the kind of the root. It configures a web page for each of the credentials, and it configures the web services. This isn't really, we're not really intending the agent to be used to build web interfaces. The interface there is more just for a demo and to be integrated within, the agencies, the issuing agency's other software. And primarily what we found is the people we've talked to, they've got other systems that produce the credentials, and then they interact via web service.
So is this web form being driven from the schema?
It's being driven from the configuration files. There's 3 configuration files that I showed you, so there's information in each of the configuration. Because there's more information than, like the schema that we
But
showed.
it's related to the schema.
It's related to the
To
schema.
change the schema, this web form has to change.
Yes, yes,
And it will, yeah.
yes. So we'll go through that a little bit in one of the examples, but we'll just get it. So, and also, like I showed you earlier, if we're trying to create a credential that depends on a proof request, then we need to also supply information about who we're creating the credential for. So what I'll do is I'll just jump into dflow. I'll do a refresh. Hopefully my credentials will show up here. Mach 2. So my credentials that I just issued automatically are showing up in dflow because it's getting that information from the TheOrgBook and from the ledger. So I can pick one of the credentials that I want to create. I don't have an existing company that I want to create, so that I want to update. I just want to create a new one. So I click on begin, and then it will show me a graph of the credential that I want to create and the dependencies, and then it'll let me walk through the sequence of steps to create each of them. So this is the one that I want to create. There's dependencies that I don't have, so I'm starting from square one with brand new. So I will go testco, December 14th. Mark 2, company number 1, attention Ian, Fake Street. And we'll make this one December 1st. Submit. It just tells me, it'll pop up a not very helpful message, but it does say success, and then it gives me back an identifier. I can use this identifier if I want to, like this is the same information you'd get back from a web service call, and then you can take this identifier and you can store it in your agency issuer database, and then you've got a reference to the credential that you just created. So if you need to update it, then this is the identifier that you need to pass along to say, this is the credential that we're updating. So if we go back to our dflow page, we'll pick the same Mark 2, and now we should be able to pick that company. Okay, there's something being cached in here because it's giving me the name of the other company that we created earlier.
Should we come that way?
No, I'm just going to try nuking the cache and then try again.
Still didn't show up.
Yeah, it's kind of weird. Let's just try it again.
Is it telling me that it hasn't seen the credential?
So
Yeah, it's not,
obviously what should be there is that that first credential has been found.
And then
It's
the
not
next
finding it,
box
which
would
would
be-
have then made the
Yeah.
next two possible to retrieve. So, as we were saying, the deflow stuff is pretty new, and obviously something's weird. Had been working.
It has
We're
been
in the demo
working.
world.
Is it pointing at the wrong network?
no, it's in dev, right? So it should all be pointing at the right network. So what I'm going to do, I'll do a slightly different version of the demo. So I will create another one, Mark 2 company number 3, attention Ian, Fake Street again.
And this registration is done automatically in the real world by subscription to the registry databases, right?
Yeah.
So I'm going to grab this ID that comes back now.
Actually, who is the verifier in this architecture? Like,
So a verifier would be a different service that wants to look at something. So if I have a registration as a company, and I want to get a business license from a municipality, they want to know that I'm a company.
yeah.
And so they would verify that
Okay,
registration.
but this is not part of this solution, this architecture.
Yeah, so that's what we're intending to show, that those boxes in that flow, those are all different issuers and different permits.
They're verifiers though too.
And verifiers, so they verify that the prerequisites have been achieved, that you have those credentials, and then they say, oh, well, you've got those, so we're gonna issue you a new credential. That gives a new credential into the OrgBook, and we can look again and see how you progressed along the flow of getting all of them. The game is to get the bottom one.
But a verifier and issuer is the same thing.
Yeah,
It's just at a
in this
different
case,
point in
it's the
time.
same thing. Is the register box on
Yeah.
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 Okay.
Okay?
Yeah.
Okay, so I've created a new one again. So I mentioned that the result that comes back is the actual ID of the credential that we created. So I'm just going to grab that for now. And what I'm going to do is I'll go back to my agent. And so I mentioned that if I try to go to my org tax, it's not going to let me create it because I need to provide the prerequisites. So what I can do here is I can give it the prerequisites. I can say credential IDs equal, and then I can give it the value that came back from the previous one. So this is the work that dflow does when it's working, is that it figures out what the prerequisites are and what credentials need to be provided. So then when I go in, when I'm providing the prerequisite credential ID to satisfy the proof request, then it lets me in and it gives me the opportunity to obtain a tax number, and it also gives me a summary of the proof that was done. And because it ran that proof, it's able to pre-fill the registration ID, which is the identifier that was created when I created the initial registration credential, and the legal name, which is also coming from that initial credential. So ideally, these two should be read-only. I shouldn't be allowed to edit those. That's a future feature.
Hang on. Okay, so does that make sense? So what happened was, you came to this form, and the form said, hey, before I can issue a credential, I have to go get and check if you've got this other credential. So it went over to the OrgBook, it sent a proof request over, it got a proof back, it verified that proof, so it would have contacted the ledger to see who was the issuer. Oh, that's the issuer I expect it to be. Then it extracted the claims, the data elements from that, and it filled those data elements in up there as the basis of the information for issuing the new credential. And then this information down here is the raw data, the raw proof that was received. So there's actually a pile of crypto in that one. There's another screen where we present it all fully, but there's a bunch of signing that's been done and verification that they execute afterwards to find out.
So that's a lot of chatter between the agent and the OrgBook. Is that it?
And it's just with the ledger? Or
So-
is there a link to the issuer?
So the issuer said, give me a proof request, and it sent it to the OrgBook. The OrgBook looked at its credentials database and said, oh, you wanted to know company XYZ. Here's a proof that that's right. Sent the proof directly to the verifier, this issuer verifier. It then looked at the proof and, as necessary, went to the ledger to check any other information necessary. But primarily, it's between the two. They sent a proof request saying, I need this type of credential from you, and I need these claims from that credential. And then this thing constructed a proof, and in constructing that, it proved that it was issued by a certain entity, that it was issued to them. They were able to prove that it was issued to the OrgBook, that it's not been tampered with. And we don't have that turned on for the OrgBook, but we have this capability is we can also check for revocation. And there's a whole concept of revocation in Indy. So the issuer could have revoked it and they would have known about it. So the prover bundles that information up and sends that across to the verifier, who then extracts the information and does whatever checking it needs to with the ledger.
And it's just a setup that it's all open, that there is no check with somebody else, okay, you can give this credential to...
Exactly.
It's just a setup.
Yes, because the OrgBook is the holder, it assumes it can give everything. But the proof, and we've done this a bunch, there's a couple of things we've done. One is to prove that we can just send individual fields. Like in this one, we only have to send enough fields that the issuer asked for. So that's specified in the proof request. The other thing is that you can take and say, I want claims from 4 different credentials. And I want in one proof request, get all of those credentials to show that you own all of them and the particular claims within all of them. So you can cross over credentials and things like that. That's the magic that Indy really brings that some of the other systems don't have, which is, and this is really fundamental to Indy and credentialing systems. So some of them give you a credential and they give you the ability to prove the entire credential. So you can't break it down. You get the credential and you prove the credential. Because all they've really done is sign the credential. You've signed and countersigned the credential and then you hand it off. But that's all of the information in the credential when that happens.
Yeah,
In
so,
Indy, the proof request allows you to specify which particular claims you want and allows the prover to say, I only want to give you these particular claims. And as I say, they can be cross credentials, and they can also be, I'm going to prove I'm older than a certain age, but I'm not going to tell you what my date of birth is. Date of birth is the basis of the information, but I'm going to prove I'm older than that, but I'm not going to tell you what my date of birth was.
yeah, so,
That's the magic that Indy, I think uniquely, is providing right now.
So-
I don't know if others are doing that. Is that
So-
right?
so just to run through that from our example. So I'm in now the services.yaml file. So this is how we configure this within the agent. So we've got 4 schemas. So we've got the registration schema with a bunch of stuff. We've got the tax. We've got liquor. And then we've got the last one, which is just called my credential. And each one of these, with the exception of the first one, has a depends on for a proof request. So the tax depends on having a registration, the liquor depends on having a registration, and then the test, our last one, depends on something that we're calling liquor and tax. And what does that mean? When we scroll down to the end, we see that we've got a section where we define what our proof requests are. So registration, which we referred to earlier, we identify what the schemas are that we're depending on and what the attributes. So for the first one, registration, we identify the schema, the registration schema, and we identify the registration ID and the legal name. And then those are the 2 fields that we showed being pre-filled on the form. The second one, so the liquor and the tax each depend on the registration. And then the last one, we just said, well, we're going to depend on all of the credentials that we've got. So liquor and tax depends on having the registration, tax, and liquor. So if you want to create a my credential, then you have to provide evidence that you've got credentials that are issued for those 3 schemas.
One more thing we've done in these is you can actually leave the attributes empty. And all it does is require that it shows you half the credential, but no data associated with it. So again, that's the type of proof you can do. That's the selective disclosure and zero knowledge proof capabilities.
So when, for example, when it says you have to have the tax number or the license number, it just has to be non-blank, is that the criteria?
Yeah, it's just looking for the presence of that credential with that identifier in it. We don't have any other business rules around. I guess the zero knowledge proof could include something a little bit more sophisticated than that.
So what this is saying is proof that you've got this credential, and when you do, send these pieces of data over. So we're asking specifically. But we can also specify that in such a way that we're asking, are you older than 21 based on date of birth? So older than, greater than, whatever date of birth, based on date of birth. So there's mechanisms to describe that predicate. So it allows you to prove in zero knowledge that information.
So the way you have it specified there, it just means send it to me regardless.
Exactly.
That's valid.
Yeah.
Yeah. So just to identify another one, so these proof requests can cross issuers as well. So we've got examples down here which we may not get to, but we can issue a credential that depends on a schema that is from a different issuer. So these last 2 are from an issuer called DFlow, which is the sample ones that we have. So we can define a new schema or a new credential that depends on something someone else issued. if we get through to the end of the workshop, you can define a schema and then someone else can define that as a dependency, and it's all handled dynamically. So then just to kind of, not to beat it to death, but if we come back to the, where's my dflow? If we come back to my dflow and we'll just, I don't know if this is going to show my company correctly or not, but we will just take a look at the graph that's being built. And then number 3. But you can see how the graph that we're building depends on the proof requests. So we have the first credential, or the first schema, the first credential that doesn't depend on anything. That's what we call a foundation credential. The liquor and the tax, which we said they're depending on the proof request called registration, which says you have to have a registration credential. And then the last one, my credential, depends on having all of the other 3. So that gives dflow the information to lay out the map. And if we give it a company, then it should also be able to say, hey, you've got a registration, you've got a tax. So it will show those as blue, and then the other 2, now you've got the dependencies, so you can link and create them. So just kind of mentally imagine the dflow working that way.
So this, what we've seen here with the schemas and the services, the purpose of those, schemas.yaml allows you to say, these are the credentials I'm going to issue. And so we take the YAML and convert that into what the Indy SDK needs to define the schema, to define the credDef, and then when we're issuing credentials to issue them. And then the services.yaml does a couple of things. One, we've seen that it says what are the proof request dependencies that we have to get. And then the other side of it is it also tells TheOrgBook, hey, here's the mapping of the credential claims, the fields within the credential, to things like names that need to be searched upon and things like that. So that's how those config files fit together.
I mean, more generically, you don't, those configuration files tell the issuer how to write, they handle all the rights to the ledger. You don't need to know anything about that. And it configures the TheOrgBook as well. So there's no programming of the org, whatever that's going to be called in Hyperledger Catalyst. That's all driven by those configuration files. Because our goal was as little programming as possible.
So,
yeah, the schema file is laid down in the ledger or
ledger?
It's
Yes.
in the ledger.
Yes.
It pulls from the ledger.
Yes.
If I reference, then I pull it from the ledger.
Exactly. Yep. Yep. The ledger contains the vids, the schema files, the credential definitions, and then the only thing we haven't shown here yet as well is when revocation is used. There are ledger entries related to revocation. So the issuer can independently revoke a credential. Ian mentioned that you get back the credential ID. You could use that then to, in the future, revoke that credential. And that does involve a right to the ledger.
okay, so the other thing I'll show you, I mentioned that when we run an agent, it provides a web interface. It also provides a set of REST services. So we'll just now issue a credential using a web service. So I've got some handy dandy test data here. So this is the JSON packet that corresponds to my registration credential. And what I need to do in the JSON is just set the values for all of these. The way we've set up the web service is that, or the way we've set it up right now is that on the web page, if you're doing it through the web page, we will do some auto generation, so we can automatically generate an identifier for the company. When we're doing it through the REST web service, we're assuming that you've got some system, some agency issuer system that's providing all that information. So in this case, like for BC Registries has a company number, so they provide that company number to us, and then that's what we use for the registration ID for the company. So the registration ID is just a string, so I can just say ID for December 14th, REST demo. And then I'll give it a addressee, which is the REST person. And a company name so that I know that it's the REST company for mock to December 14th. Very useful name. So then I'll save that. And if you're familiar with JSON, you can send multiple of these in the same request. So you can just get a group of credentials and then just post them all at once. For example, that might look like, this is hard to read, but it's an example that I use when I'm doing my local testing. I've got a registration credential, a tax credential, a liquor, a my credential, and then I also cycle through a couple of versions of each of the credentials so that I can see what happens when I'm issuing a credential that it already has. So that's just an example. So I'll save this, and then that is in this location, vonx agent test data sample registration.json. So I can just copy and paste this curl command into my play with Docker. I'll Control C here. If I Control C, the Docker containers are still running. They're still running until I specifically shut them down. So here there's a whole pile of stuff that happened, but at the end I got success true, and the result again is the identifier of the credential that was created in the OrgBook for that request. If I send multiple credentials, then it gives me back an array of results that might look something like this: success true, success true. So then I just need to remember what order I issued the credentials in, because then the results are coming back in the same order and I just have to match them up. So then if I go into the OrgBook, if I do my mock2 search again, then this is the one that I just created via the REST service. So it's exactly the same as, once the OrgBook gets it, it's the same. It's just through the web interface, there's some fields that we can generate automatically. Through the REST service, everything has to come from the issuing agency's system, whoever's generating that file.
One other thing we're adding right now is all of the labels and things you see on the screen, those are configurable, and we're in the process of switching it so that the issuer tells us what to display on the screen, because it's the issuer that knows the credential, right? So we don't want the OrgBook to know about it. We want the issuer to say, hey, this is a registration credential, so that's what you should put up on the screen there. Here are the things we call the dates that we want you to display, things like that. So all of those are controlled by the issuer.
And it's also multilingual.
It is multilingual.
So all the strings are configurable in language.
All right, I think
Where are we at?
close to wrapping up.
Are there any more questions? I think there's a lot of questions, and
So when you talk about the credential definition, you didn't talk about revocation, you guys revoke credentials.
How do we revoke
Do
credentials?
you revoke credentials?
So what we decided to do with the OrgBook, because we were a little early on before revocation had sort of settled, is the OrgBook, we're going to trust to handle the revocation for us. So what we do basically is, BC registries, for example, they will reissue the same credential. We'll count that as a revocation of the old one and issuance of the new one, and so we sort of handle it in the OrgBook. But the code we're using, the underlying code, fully supports revocation. For those familiar with Indy, generation of Tails files, we've implemented Tails server, so there's full revocation support in what we're doing. And absolutely, when we start issuing to organizations, we will have full revocation for those. We can't trust them to do that.
It's also not just about the trust, it's that in this particular case, if a new permit service comes online and they're using the org, they have to cleanse their data, because the data they have in their existing database is bad. They've got the wrong business name and so forth. And they may have an older name, so if a name change has occurred, we want them to be able to find the old name. So we don't want it to disappear from the org, right? The company, they would name, old company name, You want to be able to expose the old company name to them so they can find the record in
Our
your book.
revoking wouldn't change that, right? Because the OrgBook would still have the old credential, it just would
Yeah.
not be able to prove
Yeah.
that it's still
Not
active.
proof of
Yeah.
non-revocation, correct.
Yeah.
Yeah, we just, for the OrgBook, we could do it, we just didn't want to have that overhead. And it took us a while to figure out how to manage tails files and things like that. So we think we're happier there, and we're confident when we go to organizations, when we distribute it to organizations. But for now, we're working.
Yeah, for now, if you reissue a credential, then if there's an existing one, it'll automatically expire the previous one based on the issue date of the new one. And you can also, you can revoke. So you can issue a credential and say, it's not a new credential, it's just got an end date. So you can issue it and say that it's being ended at a certain point.
Just along the same lines, and if it's a credential that just has an expiry date of 1 year, does that have to be revoked, or
Right.
can you,
It doesn't
will
have
your
to.
tests automatically check to see if it's still?
So there's two approaches for that. I can't remember what, I'll pop open our, I can't remember exactly what we've got in our configuration, but, so there's two business cases, right? So one business case is that you want to issue a credential that's only valid for a certain period of time. So in that case, you put in the credential, I think I've got it in the my schema. So we've got an effective and expiry date essentially. So those are just dates. They go into the schema, and then from a business point of view, when you check that credential, you have to validate those dates. So the credential itself isn't going to expire, but it's got a date beyond which the credential isn't going to be accepted by the business. So as a business rule, and that's something that you have to deal with on the business side.
That would be the verifier.
That would be the verifier. So we've also got an effective and expiry date for the credential itself. So if you post a credential with an expiry date, then that credential is expired, and when you look at it in the OrgBook, it'll say, you know, sorry, this credential is expired, you can't use it for proof. So there's kind of two different approaches to it. These two dates, the effective date and the expiry date, they don't have to be called that. There's another configuration in the services where you say, you've got a credential effective date and a credential expiry date, or a revocation date rather. So you can, based on the data and the field names that you want, then you can configure if you've got a credential effective and expiry date and which attributes those correspond to.
So from an official, like from an Indy functionality, from a technical how Indy works, there is no expiration dates, so revocation is the only mechanism to actually revoke. A thing we've learned and to keep in mind is generally, and Phil kind of alluded to this, is that revocation doesn't always mean something bad happened. You know, you think of it as, oh, they had the driver's license revoked. Well, actually changing your address would revoke your credential that you have, and then the driver's license bureau would issue a new one with a new address. So they're revoking the old one, not because you crashed your car a lot, but because your address changed. So revocation is a lot more than that, something to think about, because it is going to be a common scenario in a lot of the credentialing scenarios.
So how does it work without calling home?
Revocation registry is like a zero knowledge proof.
That's outside the scope of this lab, I think.
It's like a cryptographic accumulator. It's updated by the issuer. And if you need to know more, then you got to talk to like Nathan.
There's a really good paper, actually, that if you connect with us, we can send you. So on the Indy Kite repository, there's a whole description of how it works, and it is it's pretty intense. And the thing is to prevent correlation, that it's got to be zero knowledge, and it's really powerful. But sure. Yeah.
Can you talk about the economic model behind this? Like, does anybody pay to use these credentials?
That is beyond the scope of today's course. Phil Winkley would.
No, I mean, in our case, like in the government's case, like this is a free service.
Yeah.
And that's like, it's open data and free service. I mean, we'll monitor, like in case, you know, this gets really popular or something, like maybe we'd have to put something in there to rate limit.
But maybe, what's your internal business case? in terms of
I mean-
convincing people inside
Yeah.
BC.gov that this is a useful thing to do?
Yeah. Part of it is just like even internal government services having access to this data, they haven't had it before. So like I mentioned, like every single permit and licensed service has inaccurate data in their database right now because they're relying on the business people to type in the right name, and I absolutely 100% guarantee you they don't do it right. Because I've personally witnessed it many times. And then in certain times it's bad because we might have issued a contract and it has the wrong legal name, in which case the contract is non-binding. Or other permits and licenses. So part of it is just access to accurate data, but
In a lightweight manner.
and then the other part is this is about empowering British Columbian companies to be digital. So we want them to be able to do the things that we've talked about, Mary, being able to do easier. And so that's just like a better service. But I didn't do like a big sophisticated business case, to be honest. And just like part of this was also to learn about this because our ultimate goal is digital identity. Because we have sort of already enrolled all our citizens and we have excellent data around the actual citizens. They've been enrolled through a legislatively authorized, digital identity service. But this is the only technology we've seen that could actually scale to the economy. So it's a proof of concept in that sense. This is like a production system. We happen to think we found helpful service along the way, but we're going to keep going until we get to like personal identity, being able to associate a person to a business in a way that they can control the business, that they can delegate authority to arbitrary other people. So it's kind of on the path. We've spent about $1 million on this a year for a team. And the government of Ontario and the government of Canada probably about a little less than half of that. So it's a pretty low investment considering, the value.
So I just checked the schedule. We've got another half hour. It goes till 12:50. So I don't know how, given that some of the demo stuff isn't working, but if we can do more Q&A or we can do a bit more demo around some of the credential stuff, or I don't know whatever people are
We've
interested
thrown
in.
a lot of information at you.
Yeah.
So I feel a bit bad and we didn't get to finish the whole workshop.
So the additional steps are being able to add new attributes.
Yeah, so
Credentials.
yeah, so this is just kind of the first step. The first quarter was just kind of booting up an agent with all of the credentials that we had previously defined. So we've got 3 examples. So one of them shows just creating a schema that's got a dependency on something that some other agency created. The second one, the second example, we add a new attribute. So we take an existing example and we just add a new attribute to it. Fairly simple. And the third one is multiple cardinality or multi-cardinality. Does anyone? So that just means that you can have more than one credential of the same credential type. So normally when you're issuing a credential like a registration, there's only one. So a company can have one credential. If you issue a new registration credential, then the old one gets expired and the new one becomes effective. But multiple cardinality means that you might have, for example, multiple addresses. A business can have like a physical location, a mailing address, legal address, and so we've got the capability of saying there's an address credential and we want the capability of being able to support multiple address credentials. So we can run through one of those examples or we can do some more Q&A if people have more Qs that we can A.
I have a proposal. I think since none of us really has the examples running,
Yeah.
and we can still do that later on,
Yeah.
I guess, because we have the slides, right? It may
Yeah.
be more productive to exploit the fact that you guys are here and we can have an interactive with
Yeah, absolutely. We're open to whatever you guys want to do.
if that finds
You
agreement.
might want to open this door.
Yeah, please.
There's a form in here. I don't know.
Please open the door. But I think people have. I know there's more questions. So
Yeah.
Can you explain again what actually happens when the holder giving the tax office the credential IDs, and then the tax office can dispatch all the information? So can you please explain again what actually happens when we give the credential IDs to the tax?
oh, the credential ID. Okay. So that was the case where, okay, I'll grab this. So my new company that I created, let's see if Play with Docker lets me grab the ID. Oops. So do you want to do the talking on this one?
So basically what happens when you go to this form or when you hit this API, if you haven't specified company, so it can't check if there are prerequisites already. So by specifying that ID, it's able to go to the OrgBook through the API and say, what is this, or actually no, it can construct a proof request at that point. I believe it can construct a proof request at that point to say, I need a proof request of whatever's configured, and I need it for this foundational credential. And so that enables the OrgBook to know, because the OrgBook has credentials for all of the companies, it knows which company it's checking for. And it can construct the proof corresponding to the request to send back to the tax office.
Right.
So that's what's happened. Is that?
Yeah. So this is how we've configured it. So I'm coming to my org tax. So the schema name corresponding to that URL is the tax schema, and for the tax schema we have a proof request linked to it, which the proof request we looked at earlier is depending on another credential. So what the software is doing is it's saying, oh, this is the credential that you want to issue. You know, prove to me that you're allowed to issue this credential. So I haven't given it any evidence that I'm actually allowed to have this credential or that I'm allowed to issue this credential or not. So if I go back to this screen and I say credential IDs equals, and I give it the number of the credential, this is the credential I just created through that REST web service. So then what happens is, so it's basically the same thing. So now the software is saying, okay, well now you've given me a credential ID. Let me see if I can talk to the OrgBook and get a proof request. So the OrgBook, so the agent is now saying, this is the credential I want to create, and the OrgBook is saying, prove to me that you're allowed to do it, and then I construct a request with this credential and send it back and say, here's my proof.
Okay. It's direct. It's direct connection between the tax and the output together.
Right.
Yeah.
So, and the other way to think about it is, if I was using my phone to do this, the tax ID would send me and say, I need your credential. I would click through the interface to select it. But the OrgBook's got a million to go through. So that's how the tax ID has to give me enough information so I know what I'm looking for.
And these information are publicly available to
Yes. Exactly.
And right now that the actual APIs that are communicating, they're like, we made them up. But that's where we're working to have the messaging protocol supported, which would be then implementable by anyone and generic, right?
Yep.
So then our tax agency could offer and issue credentials to anyone who conforms to the messaging protocol, not just our custom API. Like we'll change our software to conform to the messaging protocol. It's just the messaging protocol didn't exist when we built this.
Yeah, so all of this is going to be Indy Catalyst. It'll be a component with Indy Catalyst, and will conform to any of the standards that are developed by the group within Indy. Revocation, agent-to-agent communication.
Because it all uses the SDK, which will support the primitives.
When the authbook service will crash, is there enough information in the ledger to restore it somehow? Is it needed to make sure it's always up and running in a backup?
They're like independent.
Yeah, so we've got all our backups, like the Postgres backups, it's a typical enterprise database. We've got full, normal enterprise database controls. The wallet itself has a set of keys, so the primary keys that we really have to watch are the ones that encrypt the wallet. So the keys that connect to the ledger are in the wallet and they're encrypted, but and that encryption of the wallet is what we have to watch. So that's from an enterprise perspective and a key management perspective. Right now, it's making sure that we know we have the keys for the wallet, we don't lose them, and that we're doing proper backups and proper enterprise management of the data, because that's really all that we lose. We do retain the seeds we use for all the keys, so that's really what we're controlling, and that allows us to regenerate the keys necessary to resync with the ledger.
But there's basically, so we've got the information that when we receive a credential, we store the credential in the wallet, and that's kind of the Hyperledger Indy model. So all the information is in the wallet. We also there's a second database that we keep some information in for searching, because searching through the wallet for certain types of searches is just very inefficient. And we've got like a Solar search engine as well, so we keep all of that information outside. But we've got the capability of rebuilding all of that. So if for some reason any of that becomes corrupted, we just say rebuild, and it goes through the wallet and it refreshes all the information in the other stores. And the information that's on the ledger is the DIDs, so the identity, and the schemas and credential definitions. So that doesn't change very often. Right now in our production system, we've got one issuer and 3 credentials that they issue. So we've got maybe 8 things that we write to the ledger, and then all the other information is just in our local databases. So then it's just regular enterprise systems management to make sure that that information's all maintained.
Any other questions?
Does everyone feel that they've got like a good understanding of Hyperledger Indy, or at least relative to when they came in the room?
One question. So if the different credential expires, so how is the base credential gets updated? Because there's a dependency. How is that resolved? Is that resolved runtime or?
So what happens in a traditional Indy case where an issuer has issued a credential into a person's wallet, what happened is the issuer can at any time say, I revoke that. And that involves writing something to the ledger. They can, they don't have to, they can inform obviously the person, they can message the wallet of the person, the agent of the person, and say, hey, I just revoked the credential. If the revocation was because they just reissued a new one, they would probably say, hey, I revoked it, but here's a new one you can have. And then that person would request the credential and get the new one. But that's kind of the model that Indy has. When the person then goes to prove that credential again, they can prove that it was issued, they can prove that it was issued to them, they can prove it's not been tampered with, but they can't prove that it hasn't been revoked. So that fourth piece of the proof, when they send the proof over to the verifier would say, hey, this has been revoked. I don't accept this. It's up to them. Then it becomes a business question, right? It used to be that you could cross the border with an expired passport. I don't think you can anymore, but you used to be able to. So it's up to the business to decide, hey, are we going to allow this? It gives us the information. We know it was issued. We know it was issued to that person. It's revoked, but does that matter to us? It all depends on what your business case is. Where we get into all sorts of interesting things on revocation and why I direct you to the paper versus what we can talk about is it's all in timing, right? They can issue me a proof request. A verifier can send me a proof request. I can prepare a proof, and after I send it, the issuer revokes it at that second. The verifier is going to think it's not been revoked, so there's this time window component that comes into it that gets really interesting. And so it's done right, but it gets your head spinning a little bit to figure out how you manage that. What time frame is the verifier going to accept the revocation or the last check of revocation? Because it's, and again, this is an interesting thing. It's the prover that proves that it's not been revoked. The verifier can't get a credential and then every once in a while check to see if it's been revoked. They actually can't do that. It's part of the zero knowledge proof mechanism for revocation. So again, getting a little into the weeds there, but the paper's really good about explaining how that all works.
Is there a link to the paper?
I can send it to you, and maybe we'll put it into this slide deck. Since you've all got that, we'll put it into the slide deck. How about that?
Yeah, I think two useful kind of appendices to the slide deck are kind of links to some of the kind of the core Indy information, and then also a description of how to get the whole kit and caboodle up and running locally. So the Vaughan network, the OrgBook, and so forth.
And you can always take the Indy blockchain for business edX course, where the Indy chapter was written by me.
What's your phone number?
Plug.
You can probably Google it.
So,
I think that's it.
yeah, I'd like to thank you a lot for tolerating our very first large-scale workshop. You know,
It was
rough.
definitely a good lesson for us.
And, let us know. I mean, obviously, that's a big work, but let us know what you thought. And, look forward to continued discussion in the community.
Yeah, and the best, I think, if you do kind of decide to later on try and go through the workshop on your own, then the best way to get hold of us is probably on the Hyperledger Rocket Chat. So you can just ping us on there, and we keep an eye on it.
Like the Indy channel or Indy SDK.
Or even just PM us, and
Yeah.
yeah.
Thanks a lot.
Yeah.
All right.
Thank you.